Good afternoon, everyone. This is Bahnisikha Das, Senior Lecturer in the Department of Civil Engineering from IIMT College of Polytechnic. So today we will be discussing on a topic, sources of water. So this topic is particularly topic I have taken from a subject called Water and Wastewater Engineering, which is in the 5th semester of Civil Engineering Department in IIMT College of Polytechnic. So the reason for taking this subject is that this particular subject, water and wastewater engineering, is a combination of two different subjects. One is the water supply engineering and another one is the wastewater engineering. So as we know that water is the most essential element in our day-to-day life. We cannot survive without water. We use water in almost all our activities. So in water supply engineering basically deals with the collection, treatment, and the distribution of water from the source to the individual houses or factories or industries. So water which we are getting in our day-to-day life is because of this entire arrangement of the distribution work of the water supply engineering. And the second part of this particular subject, that is wastewater engineering, it basically deals with the collection of the used water from the individual houses or factories or industries. So it deals with that used or waste water, and then the treatment of that wastewater, and then disposal of that wastewater. As we cannot dispose the wastewater directly into the environment because it will lead to environmental pollution. So we have to first treat the water because it may contain many contaminants or bacteria which need to be removed before we dispose it off to the environment. So this is all about this subject, water and wastewater engineering. So coming back to the topic, sources of water. Sources of water is actually a place from where we will be getting the water. Now, the entire source of water is basically divided into surface source and subsurface source. So surface source of water basically deals with the water that is available above the earth's surface in the form of lakes or ponds or rivers or oceans, etc. However, subsurface source or groundwater source is the one which is available beneath the earth's surface in the form of infiltration galleries, infiltration wells, um, then bore wells or digged wells or springs, etc. So surface water, since it is present above the earth's surface, so it is directly exposed to the atmosphere. So it is also exposed to all the atmospheric pollution. So surface water is said to be more polluted as comparison to the subsurface water. Then another characteristics of surface water is that surface water also includes the suspended solids, many suspended solids, and hence in appearance wise it may not look very pleasant with our naked eyes. However, subsurface water does not contain any that suspended solid. The reason behind is that whenever the water reaches the subsurface sources, like the underground sources, it goes through the, so it infiltrates through the soil and then it reaches the underground sources. So during this process of infiltration, it undergoes all the filtration. So all the suspended solid are trapped by the soil, and then only the clear water goes inside the soil. The only solid which may be present in the subsurface source or groundwater source is in the form of dissolved solid. Only the dissolved solid may be present. So appearance wise, it looks very pleasant as comparison to the surface water sources. However, it may also need to be treated depending upon the dissolved minerals or dissolved gases that is present in the underground sources. Next, we have the requirements. Before selecting a particular source, there are many factors which needs to be considered. So one of the most important factor is the quantity of water. As I mentioned, that water supply engineering basically deals with the distribution of the water, the collection, treatment, and the distribution of water to the individual houses or to the factories or industries. Now, this distribution of water or the collection of water, it depends upon how much quantity of water required to be distributed. See, if you are distributing certain amount of water, that depends upon the demand of water. Now, what is the demand of water for a particular city or for a particular town for which the water supply scheme is being designed? And based on the demand, the water is distributed. Because if you are distributing the water lesser than the demand, then of course it will not meet the requirements of the people residing in a particular town or a city for which the water supply scheme is designed. So the uh, first requirement that we need to meet for selecting the source is the quantity of water, because we have to supply that much quantity of water to the individual houses or factories which is required, or which is as per the demand of the water. So first thing that needs to be seen is the quantity of water, whether that source is giving us sufficient quantity of water as per the requirement or not. First, we have to see that. After we get the quantity of water, we will also have to check its quality, because quality also plays an important role. If we are getting sufficient water from a particular source, sufficient quantity of water if we are getting from a particular source, but the quality is not good, or if the quality is very poor, then of course the budget will be very high for treating the water. We have to treat the water to a higher degree, and hence the budget will be very high. So we will also have to check whether the quality is sufficient also to meet the demand, because it plays an important role in economy as well. If the quality is not good, we have to go for higher degree of treatment, which will require higher budget or higher economy. So these two things need to be taken care of. First one is the quantity, that we are getting sufficient quantity from the source or not, and then we will also have to see that we are getting sufficient quality or the good quality from that source or not, as per the requirement or as per the demand. After that, we will also have to see how far the source is, or how distant the source is, whether this source is available in the nearby areas, or whether it is very available in a very far areas, because that will include the transportation cost. If the source is at a very high, like far away areas, then the entire cost will go on in transporting the water from the source to the treatment plant. So we have to also see that whether that source is available in the nearby areas with sufficient quality and quantity or not, because the economy will depend up not only on the quality of water, the economy will also depend upon the transportation cost, or how far the distance, how far the source is. Because if the source is available at a very far area, in a very far place, then the entire cost will go in transporting the water from the source to the treatment plant, because we will have to construct such structures for carrying the water, such as may have to construct the canals, or we may have to construct pipelines for transporting the water from the source to the treatment plant. So we will also have to see that whether the source is available in the nearby areas or not. So all these three things need to be taken care of. First is the quantity, that sufficient water we are getting from that source, which again depends upon the demand of the water. Next, we have to check whether we are getting sufficient quality from that source. Because otherwise we may have to go for higher degree of treatment, which will require more budget. And then third, we have to see that whether the source is available in the nearby area, so it is very far, because otherwise the transportation cost will be more or less accordingly. So based on these three requirement, we have to select the source of water. Next, coming to the sources, we will first discuss with the surface sources of water. So as mentioned previously also, there are certain sources. One is the ponds or lakes. The ponds or lakes are not exactly the same thing. They vary in terms of their size. Ponds are smaller in surface area as well as in depth as compared to the lakes. And since ponds are smaller in surface area and depth, so their ecosystem is also different as compared to the lakes. However, both the structure is same for both, like both contains accumulated water. In ponds and lake, both contains accumulated or stagnant water in an enclosed area. The water does not flow in case of a ponds or lakes, it remains stagnant in a position. And for this reason, they become the breeding place of many microorganisms or aquatic plants or animals. For that reason, the water is not of very good quality to be consumed. The water may look pretty from with naked eyes, but they may contain many dissolved unwanted materials because of the breeding of microorganisms or aquatic plants or animals. So they cannot be consumed without any treatment, and for that reason they are not considered a very good source of water. And not only that, since the water remains stagnant, the water may get dried up during the dry and hot season. So water may not be available throughout the year also. So not only quality wise, even quantity wise, we may not get sufficient water if we rely on ponds or lakes. However, in certain villages or for a small water supply scheme, if no other sources are available, then ponds or lakes can be considered as temporary source of supply of water, especially when the water is available in sufficient quantity after giving it a small treatment. Next, we have seas or oceans. As we all know, that the water, out of the total percentage of water that is available on Earth, almost 97% of water is coming out from seas or oceans. So there is no question in terms of quantity as far as seas or ocean are considered. We will get ample quantity of water from seas or ocean. But the main question here lies in the case of quality, because seas and oceans, the water is very salty. So many dissolved or even suspended salts or minerals are present which may be toxic in nature. So requires high level of treatment, high degree of treatment. Some desalination techniques are required in case of seas or ocean, so that we can remove all the dissolved salts or minerals from them, and then we can use them. So this desalination techniques are very costly and uneconomical, and for that reason, this is the water coming from seas or ocean are not considered a very good source. But in places where there is no other source of water available, for example, in UAE, that is in Middle East, there is no other source of water. So the people residing in UAE, they rely on the water coming out from seas or ocean. They undergo them, they treat the water, they desalinate the water, and then they use it. Next, the most reliable source is the streams or oceans. Again, streams or rivers. Again, streams or rivers are not exactly the same thing. Rivers are the larger bodies of water, floating bodies of water, and streams are the smaller channels which are coming out from which travels from a mountains and all. But rivers are a longer and larger channels of water which carry water to longer length as comparison to streams. So river waters are the most reliable source of water. Almost 70 to 80% of Indian people, they rely on this particular river water, because the water here is not stagnant, unlike ponds or unlike ponds or lakes. So water keeps flowing, and since the water keeps flowing, so it flows with a minimum velocity of 0.45 meter per second, and which is considered as a self-cleansing velocity of water. Because as the river water flow, if there is any suspended particles present in them, due to its flow, it will either settle down the water at the bottom of the river, or it will carry away the suspended particles along with its flow. So cleaning by cleaning that particular area, wherever any discharge is made in a river, so in that particular point of discharge, the water, since the water keeps always flowing, so with its flow of water, it will either settle, the particles will either settle down at the bottom, or the particles will be carried away with the flow of the water. And for that reason, they have a particular self cleansing velocity. To a certain extent, they have the self purification process. So the river water are much cleaner as comparison to a lake, the water that is available in a lakes or ponds. And for that reason, that river water is considered as one of the major source of water, which is not only used in India, but is also used in many other countries for taking the source, for considering it as a source. So if the river water is available all throughout the year, then it is, of course, the water is taken from that area. And if the water is not available all throughout the year, then some artificial hydraulic structures are constructed where the water is stored during the period of excess flow of water, and that water is utilized later in the during the dry season, when the water is not available in the river. The water does not flow naturally in the river. Okay, so that the reason river water, and even the treatment of river water, is not much costlier as compared to the other sources of water. So for that reason, river water is considered one of the major source of water in the water supply scheme. Next, we have the storage reservoir. So storage reservoir is an artificial depression which is constructed by digging a hole, and then water comes into it from the environmental source, and that gets stored in that particular area. So that is actually considered as a source for a very small city, but it is not used for a public distribution system, because like in ponds and lakes water, where the water remains stagnant, here also in storage reservoir also the water remains stagnant, it cannot flow, because it's an artificial depression that is being constructed for storing the water, for that reason. And moreover, since the water remains stagnant, it may get evaporated during the dry season, so water may not be available all throughout the year, so it is suitable only for a very small area with limited population. The water, it can serve the water of a very small area. So those are all the surface sources. Next, coming to the subsurface sources, first we have the infiltration gallery. So infiltration gallery, as seen in this picture, it is nothing but it is actually a structure which is constructed along the bank of the river. As we can see here, it is a chamber which is constructed along the bank of the river. So this chamber is a machinery chamber, and above the chamber there is an RCC slab with a manhole provided for inspection and maintenance purpose. So what happens here is that this is an RCC chamber, and there is a pipe, perforated pipe, which is connected. So there is series of such chambers constructed along the bank of the river, and all these chambers are connected to each other with the help of these perforated pipes. So what happens is that this kind of chambers, these are constructed in an aquifer. I will now discuss what an aquifer is. Aquifer is nothing but aquifer is a geological formation which not only stores water but also it yields sufficient quantity of water through it. Okay, so any such chambers are constructed in an aquifer only because it will store the water also, and it will also allow the water to pass through it. Okay, so that we can take out that water. So such chambers are constructed in an aquifer. As we can see, this is a river and this is the water table, right? And below the water table, this chamber is constructed. Okay, so that whatever water is there within this entire geological, the entire soil, that water enters into this chamber through this perforated pipe. Like there's the perforated pipes, and the water enters through the chamber in this through these perforated pipes. There is one more thing which is not shown in this picture, that is there are some stones which are provided around this perforated pipe, so that whenever the water seeps down into these perforated pipes, the water seeps down without any soil, so that it does not carry any soil along with them. Okay, so the soils are being trapped by the stones, and only the water is entered through these perforated pipes into this chamber. So there is a series of chamber constructed along the bank of the river, and those series of chambers are connected through these perforated pipes. Okay, so all the water that is available in this particular geological formation, that water will enter into this perforated pipe, into this particular chamber through these perforated pipes. And stones are provided surrounded by these perforated pipes, so that only the water enters and the soil is being trapped by these stones. Next, from all these chambers are connected to a particular sump well, and then the water from all this chamber, it is taken to the sump well, from where it is taken to the treatment plant for treating the water. So this kind of construction, it is done. However, the quality, though since it is a groundwater, so we will get a very good quality of water, but it is not used for serving a very huge population. Okay, because we cannot get ample quantity of water from such construction, and we cannot serve a huge population from such construction. So if there is a small village or a small town, then the water supply scheme can be can use such sources for supplying the water, because in such arrangements, to a great extent, the treatment cost will be reduced, so that cost can be balanced by the construction of such structures. Next, we have an infiltration well. So infiltration well, it is again a structure which is a well which is constructed. These are also constructed along the bank of the river. These are also constructed in series along the bank of the river. However, the construction is made in such a way that, as we can see, the top of the well is covered by providing a manhole, and this is the groundwater surface, and there is a river around them. So all the river water so that all the river water will seep through the soil and come into this infiltration well. These are constructed in such a way that these wells are open at the bottom and they are closed or covered at the top. These infiltration wells, these are open at the bottom. As in the bottom, these are open, and in the top, these are covered. So all the water which is coming or which is seeping through the river, because of the head difference or because of the pressure difference uh, from the river to this particular area, the water will seep into that area and it will be filled into this infiltration well. After that, the infiltration wells, all the infiltration wells are connected to a particular jack well through porous pipes from where the water is taken to the treatment plant. So the structure is similar, the working is similar as compared to the infiltration gallery, but the only difference is that in case of infiltration gallery, the water is entering into in the first case, we have seen that the water enters into this perforated pipe from where the water enters in this particular chamber. However, in case of a well, infiltration well, the wells are covered at the top and they're open at the bottom, and there is a river surrounded by, like, because these wells are constructed along the bank of the river. So from the bank of the river, the water will seep, the river water will seep, and because of the head difference or pressure difference, the water will enter into this well. Okay, as the water will keep entering till the head becomes equal, and then through the well, all these wells are connected to a particular jack well from where the water is taken to the treatment plant for treating the water. However, since these are underground water, so the treatment is very less, the treatment cost is very less in such cases. Next important underground source is the spring. So springs are encountered generally in hilly areas. So they are formed wherever there is an interface of two impermeable strata. Okay, as we can see in this picture, uh, this is a water table. Here, this is a water table. Okay, beneath is an impermeable structure. Impermeable strata means those strata which does not allow the water to pass through them. Okay, so since this is a bedrock, there is no water, it does not allow any water to pass through them. And above also there will be an impermeable strata. Okay, so springs is the jet of water which is coming out at the earth's surface, and that water is confined in between two impermeable strata. So wherever that water is finding its way into the earth's surface, that water is coming into the earth's surface. Okay, which is confined in between two impermeable strata. So since it is confined in between two impermeable strata, the water is at a very high pressure, much greater than the atmospheric pressure. So wherever it is getting its path to the earth, to the earth's surface, it is coming out at a very high speed, like a jet of water. So it's a jet of water which is coming out into the earth's surface, and which was actually confined under pressure beneath the earth, which were actually confined under pressure in between two impermeable strata. So that is nothing but that is a string. So such structure or such formation can be obtained only in the high, like hilly areas, and for that reason, springs are available only in hilly areas, because in hilly areas only we can get such type of formation where the two impermeable strata are then connected back to the earth surface, like they are coming its way, finding its way to the earth surface. So next, as I have mentioned, one particular geological formation, that is aquifer. There are various geological formation. Okay, so first I have already discussed. First one is the aquifer. So aquifer is, as I mentioned, it is a formation, geological formation, or it's a type of soil which not only holds sufficient quantity of water, but it also yields or transmits sufficient quantity of water from them. So whatever the groundwater sources, the water which is available to us in the form of groundwater source, that water is available, so if that water is available in the aquifer, only that much amount of water is only available to us in the form of groundwater source. So one of the example is the sandy soil. If the water is stored in sandy soil, then it will hold sufficient quantity of water and it also allows sufficient quantity of water to pass through it. Next, we have an aquifuge. Aquifuge is a geological formation which neither holds any quantity of water nor it allows, since it does not hold any water, so there is no question of transmitting any water. So such example is rocks are completely dry, its pores are not filled with water. Next we have the aquitard. So aquitard is a geological formation which holds the water, but the quantity is less as compared to aquifer. Similarly, it partially allows the water to pass through them, so the that quantity is also less than aquifer. Like it partially holds the water and it partially allows the water to pass through them. For example, it's silty soil. It does not allow all its water to pass through them. Next geological formation is aquifluid. Aquifluid is the one which holds sufficient quantity of water, but it does not allow the water to pass through them. For example, is clay. As we know, the clay can hold sufficient quantity of water, but clay water does not pass through clay, and for that reason only, clay is used in making many utensils and all, because we can hold the water in clay because it does not allow the water to pass through them. Next underground resource is the groundwater resource is the borehole. So boreholes, these are a narrow deep holes which are drilled or excavated into the earth's surface for various purpose. The depth and diameter of the boreholes actually depends upon the geological formation, depends upon the geological condition, as well as upon the purpose for which we are drilling the holes. So they are generally constructed in areas where the rainfall is very scanty. Hardly we get any rainfall, so we only have to rely on the underground sources for source of water. So the depth of the boreholes, it varies from 300 to 500 feet. However, it is an expensive process. Drilling the borehole is very expensive. Next, we have dug wells. Dug wells are the shallow wells, which are approximately at a depth of 30 feet, and they are constructed uh, so that the groundwater can be extracted. Okay. However, that is not a very good option for serving a huge population. It can serve a very limited population in a small town or area. So these are the various sources of water, surface and subsurface sources of water. I hope I would I could make it clear. Thank you.